So here it says, after finding the area from the dimensions of the first polygon, find the area of the similar polygon after finding the similarity ratio. So what we're going to do, these two figures are similar, these two rectangles are similar. We're going to find the area of the rectangle we know all the measurements of, the small one, and then use that in the similarity ratio to find the area of the bigger red rectangle. So for that smaller, it's a rectangle. The smaller rectangle has a length of 3, a width of 2. The area of a rectangle is length times width. So the area of this rectangle is 6 centimeters squared. Now the similarity ratio is found, since these are similar figures, if you find two corresponding sides. We know on the red rectangle that this bottom side is 6 centimeters. So let's look at the bottom side of our blue one, and we see that that is 2 centimeters. So this is how I would write the ratio. I'm going to write it as a fraction because I know in step 3 I'm going to be setting up a proportion, which are two fractions that are equal to each other. You can simplify this if you want. 2/6 is the same as 1/3. And just as a side note, ratios can also be written like this or like this. So now we're going to set up a proportion to solve and find the area of that big red rectangle. So this area proportionality theorem states that if the similarity ratio of the two figures is A to B, or in this case 1 to 3, then the ratio of their areas is A squared to B squared. So if this is our A and this is our B, then we're going to change that to 1 squared and 3 squared. So let's set up our proportion for step 3 and fill in that 1 squared and 3 squared. Now I'm using colors to kind of remind myself that my numerator numbers include my small rectangle values, and my denominator, the bottom numbers, include my big rectangle numbers. So if you don't use colors, it's good to write yourself a key like this, because the biggest mistake that is made in solving proportions is putting numbers in the wrong spot when you are completing your second fraction. So like on this one, the second fraction includes our areas. We do know the area of our small rectangle is 6 centimeters squared. Do I put that in the numerator or in the denominator? Remember, my small ones are in my numerator, so I'm going to put that 6 right here. And I don't know the area of my big rectangle, so I'm going to call that x. So this is my proportion that I'm going to solve. I'm going to start off and change 1 squared. That's just the same as 1. And 3 squared is the same as 9. And now I'm going to cross multiply to solve this proportion. So I'm going to multiply diagonally. 9 times 6 is 54. And 1 times x is 1x. So x equals 54. So the area of my big rectangle, that's what x represents, is 54 centimeters squared.